Hey there. Good afternoon, Mr. Chang, back with another iXL tutorial. This is how to do HHS in iXL. Here we go. You guys should be seeing my screen right now. And there are two things that you have to have open when you're doing any of these transformations. First and foremost, you got to have your transformation notes open. I don't know how you can do any of these without having transformation notes and C53 worksheet open. These are all the rules for how to execute transformations and specifically what math operations you need to do with each set of ordered pairs, with each set of coordinates. HHS is particularly tricky, so we are going to keep our eyes focused right here on HHS. So make sure you have this open and you are staring right here at all the rules you need to do rotations. Again, if you are looking for your transformation notes, they are in Schoology in your week 8 folder. Okay, so go to your course, go period 1. You're looking in week 8. Right there, transformation notes. You need to click on that. You need to get these notes up. And if you made a copy of them, look in your Google Drive. Hopefully you made a copy of your own notes. Make a copy. And you have these somewhere saved in a Google Drive, because then you can, type little notes to help you understand better. Because the way I write it, the way I'm telling you to do it, it may not make perfect sense to you. So put your own words in there. Anyways, let's get started. So I'm going to put these off to the side. I've now got HHS open. Rotations, find the coordinates. Let's get started with this problem. Remember, a rotation, you've got multiple quadrants, and you want to see how things move when you're rotating them around. So first and foremost, we are going to rotate this point, S, 180 degrees counterclockwise around the origin. So here's your origin at 0, 0. And so you're going to go 180 degrees over here to S prime. And you got to figure out exactly what coordinates S prime are. Now, if I am looking at this problem, first thing I'm going to do is I'm going to read it. The point S, -2, -1, is rotated 180 degrees counterclockwise around the origin. What are the coordinates of the resulting point C prime? And so I just highlighted the main words that I need. These are the math vocabulary words that tell me what I need to do. So I'm going counterclockwise. So now I flip over to my notes. And I find rotations, I'm doing HHS, and then a 180 degree rotation, and there's my rule. Flip the signs of the X and Y coordinates. I have it written out for me. I have it algebraically right there. Algebraic rules. That just means symbolic. Algebra, just think of symbols. So I'm using X and Y and the minus sign to tell you exactly what to do. Those are the symbols. That's what algebra is. Next year, when we're in algebra together, that's what you're going to be doing. For 180 degrees, we actually don't need the direction. It doesn't matter. So clockwise, counterclockwise, it doesn't matter. We're good. We're going to flip the signs of the X and Y coordinates. I am going to copy this. And I'm going to paste it on the next screen so you can see what we're doing. Right there. Drop that in there. Flip the signs of the X and Y coordinates. So what does that mean? It means S is -2, -1. And if I'm going to flip the signs of the X and Y coordinates, I'm just going to change the negative to positive, on both of them. So when I say flip the signs, I mean change negative and positive signs on each number. So if it's negative, it becomes positive. Negative becomes positive. And if it's a positive number, it becomes negative. And you're going to do it for both the x and the y coordinate. You don't do anything else. So -2, this is -2 on the x, this is -1 on the y. There's where s is. When you rotate it 180 degrees, you end up at +2, +1, and there is s prime. So go in here. My original coordinates were -2, -1. Now I'm just going to change it to 2, 1. And you can see, again, before I hit OK, this is, we moved it one quadrant clockwise, right? Clockwise, going with the hands of time. And then we moved it another 90 degrees. And there we go. So if you drew a line right here through the origin and those 2 points, you would see a straight angle 180 degrees. That's what it all means. That's how you do this. Let's move on. What do you say? Keep it up. All right, iXL, we are going to keep it up. Here we go. Point Q 6,4 is rotated 90 degrees clockwise around the origin. What are the coordinates of the resulting point? 90 degrees clockwise. So let's find the rule for a 90-degree clockwise turn. CW is short for clockwise. So again, go to my notes. 90 degrees. And now I got to find the direction clockwise. It says switch the x and y coordinates, make the x negative. Lots of stuff going on here. I'm going to copy that. I'm going to go over here. I'm going to paste that rule in so you can see it on this screen. Okay, switch the x and y coordinates, make the x negative. Wow, what does that mean? So here we go. My coordinates are, oops, draw, bing, bing. I'm gonna use blue, love blue. My coordinates are 6, 4. So the first thing I'm going to do here is switch the x and y coordinates. There's 2 instructions here. So the first one is to switch the x and y coordinates. That means I'm going to change where they are. The y becomes the x and the x becomes the y. This is the switch. So step 1, switch, gets me to 4, 6. I have switched their position. This is your switch. Okay? Now, step 2 is a little more tricky. This is definitely a place where if you want to change these notes and make them a little easier for you to understand, please do that. But the next step is to make the x negative. That's step 2. Okay? So step 2, make x negative. That means I'm changing the sign. Okay, so if it's a positive number, it's going to become negative. If it's a negative number, it's going to become positive. So my coordinates are 4, 6. I've switched the signs. Now, this 6, right, the x is 6. This is the original x, okay? Even though I made it now the y, I put it in the y position, this is the one that I have to switch the sign of. So the number 6 is the one where I'm going to make x negative. I'm going to do that to the number 6. So what happens is it is 4, -6. That is my final answer. And when I say make x negative, that means flip the sign. So if it's positive, it becomes negative. And if it's negative, it becomes positive. And I've said this before, but again, if you have a positive number and you make it negative, it becomes negative. Like 4 becomes -4. If you have a negative number, like -4, when you make it negative, you go negative, -4, and 2 negatives become a positive, and it becomes just +4. So let me erase all that. And our answer is 4, -6. I'm going to put that in there. 4, -6. 4 is your new x. -6 is your new y. And let's just plot this out so you can see what is happening when you do a 90-degree clockwise rotation around the origin. Here's your origin. There you go. So clockwise would put you, here's 90 degrees, draw a little square. Now put you like right here, and our new coordinates are 4, 1, 2, 3, 4, and then -6, which is right over here. So that is your new point. And let's just see, do we have a full 90-degree clockwise angle here? So remember, we're going from the origin to Q, okay, and then we're going from the origin down to this new point, which is 4, -6. That's our Q prime. And that looks to be about a 90-degree right angle. So we traveled exactly 90 degrees clockwise with the hands of time right there. That looks good. Let's submit this. Yes, good job, us. Good job, us. All right, another point, 270 degrees counterclockwise around the origin. This looks good, but I'm gonna take this up a notch and we're gonna do a harder problem. We're gonna jump a level. We can go to 32. You know what? I'm going to do a little harder one. We're going to go to 90. This is a 90. Look at this. What are the coordinates of the vertices after a rotation of 270 degrees counterclockwise around the origin? If you scroll down, you can see that there are 4 points that we have to put coordinates for. 4 points. So whenever you get to a SMART score of about 30 or 40 and higher, it takes you from rotating single points to rotating figures, triangles, quadrilaterals, parallelograms like this, squares, rectangles. And so you're going to have to do these rotations for multiple points. Now, when you do these rotations for multiple points, you definitely want to have your notes. You got to have your notes. Right? I don't know how you're going to do this without your notes. Make sure you have your notes. And I'm going to teach you a couple pro tricks for what I do. So use all your brain power, follow along. You can do this on your screen, but you definitely should also have your notebook handy. And you probably want to keep all of this kind of handy on your notebook. Okay? Now, write the coordinates of the vertices after a 270-degree counterclockwise rotation around the origin. So first, I need to understand what vertices means. Vertices are your corners. Corners of your square. So we've got parallelogram A, B, C, D. So A, B, C, D. They put our coordinates in here for us. That is wonderful. Now, 270 degrees counterclockwise. I'm going to go look for this rule in my notes. And again, here I am, rotations, 270 degrees counterclockwise. Switch the X and a Y, make the X negative. So I've got my rule. And I'm just going to put my rule here so that everybody can see it. There you go. Counterclockwise. Switch the X and the Y. This is 270 degrees counterclockwise. Switch the x and the y, make the x negative. So remember, this is two things you have to do. The first is to switch the x and the y. The second is to make the x negative. So I'm going to make this clear. What is what? In our first rule, I'm going to keep it blue. The second rule, I'm going to change this, make this green. So you can keep track. Oh, actually, I can't do that. So there are your rules. Switch x and y's to make the x negative. Now, let's do this one by one. I'm going to use blue here for the first part. Switch the x and the y. This is the first thing we need to do. And we are going to flip-flop all these coordinates. Switch the x and the y. So for every single one, you're going to switch the x and the y. This is your switch. Step one. Okay? So step one is to switch everything around. So instead of, actually, I'll do it right here, switch. So instead of 0, 9, it's going to be 9, 0. Instead of 8, negative 9, it's going to be negative 9, 8. Instead of 9, 0, it's going to be 0, 9. And instead of 1, 0, it's going to be 0, 1. You can see that I took each x coordinate and I switched it with the y and vice versa. We're just flipping all these coordinates around. So that's the first thing you're going to do. The second thing you're going to do then is to make the x negative. Here's number 2. Use purple. Make the x negative. So 2, make x negative. And remember, what that means is to switch the sign. If it's a positive number, it becomes negative. And if it's a negative number, it becomes positive. You're going to switch the sign. And the other thing that is important to know is that I'm working on the x coordinate, the original x, right? The first number here, I'm highlighting it in purple. Take a look. These are the x's that I'm going to change the sign on. I'm not going to change the 9, the negative 9, the 0, and the 0. I'm going to change the 0, the 8, the 9, and the 1, the original x. So if you look at the algebraic notation, the x moved into the y position and we got to make it negative. That's what we're doing. So we're going to go 9, 0. There is no way to make a 0 a negative number. You're going to go negative 9, negative 8. You're going to get 0, negative 9, and you're going to get 0, negative 1. And I will go through here and use this little red. And this is the change that I made right in there. And I'll tie it back to that. Okay? So those are the things that you have to do to do a 270 counterclockwise rotation around the origin. Switch the x and the y, make the x negative. It's 2 steps times 4 vertices, which means that you did 1, 2, 3, 4, 5, 6, 7, 8, 6. You had 16 individual operations that you had to execute. This is a lot of math. This is a lot of math, okay? 16 operations in just one problem. Good job, guys. All right, now, here is a pro tip, The pro tip is to do all of these right in here. And the first thing, the way that I'm going to do all of this is let me just erase. I mean, the great thing about video is if you ever need to go back and look at something that I wrote on this screen, you can go back and do that. So if I'm going to erase this stuff and you're like, oh, Mr. Chang, please don't erase. Don't worry. Pause the video and just go back and look at what I wrote. And then you can have your own notes. Anyways, here we go. What I like to do is I like to start off by just putting in the original coordinates just as they are exactly written, as if no transformation has happened. And then I go by and I go one by one. So the first thing I'm going to do is switch the X's and the Y's. So now I go through and I do the switches. And I just go in and reverse everything, flip them around. And then I go in the second time and I do the second piece, which is to make the X's negative, the original X's. So I wrote all these great notes here. So 0 stays the same. Then I go and make a -8. Then I go and make a -9. These are the original X's, remember. There's the -1. Even though we move the X into the Y position, we are going to make the original X's negative. All of these guys. Okay, that's what I just did. I'm done. I am totally, completely done here. Now, before I hit the submit button, I just want to show you guys what I did and what this actually all means. Like, what did we accomplish here? So I'm going to erase everything. Again, don't freak out. And I'm going to plot these points and show you. So we took this parallelogram and we're going to rotate it counterclockwise 270 degrees, which is 3 quadrants over. So it's going to end up counterclockwise around the origin. Counterclockwise is this way. So it's going to go 1, 2, 3. So we're going to end up over here in this quadrant. And let's see how this looks. So my first point is going to be point A, which is at -9, 0. -0, -9. Ooh, this is interesting. That doesn't look like that's right to me. -9, 0. 270 degrees counterclockwise. I figured it out. I was going clockwise. This is wrong. Thank God I'm doing this out. Anyways, so I'm going this way. This is counterclockwise. 1, 2, and 3. I'm going to end up in here. Okay, now this makes sense. All right, let's go. So here we go. -9, which is over here in 0. So that's point A prime. -9, -8. So I am at -9 on the x-axis, and I'm going to go down to -8. That's 10, 9, 8. So right there. So that is B prime. And then I'm going to go 0, -9. So 0 and then -9, which is right here. And that is C prime. And D prime is at 0, -1, 0, -1, which is right there. That's D prime. And now look at my beautiful parallelogram. It's actually not a parallelogram. It's a rhombus. Okay, now look how this A went all the way around here. And look how B went all the way around. Oops. Look how B went all the way around to the other side. Look how C went all the way around down there. And D went all the way around here. Okay, that is a 270 degree rotation. Each point rotating around, you can see that the object is has totally moved around, has a different orientation, and all the points have kind of, I don't want to use the word flip because that would say reflection. They've rotated all the way around. And if I were to draw this out, and I'm going to use a different color, I'm going to use blue, and just trace the journey of point A, or actually I'll do point B. Trace the journey of point B around the origin, 270 degrees. I'm going to draw the dot, the origin at 0, 0 there. Draw a line. I'm going to draw the line going from D down to B. Let's see if I can do this on the computer kind of straight. And then draw another line from the origin down to the new B prime, which is right there. This angle is 270 degrees. The measure of that angle is 270 degrees going counterclockwise, okay? So it's like 3 90-degree moves. So this is 90 degrees. A straight line going out here would get you to 180. And then another square there gets you another 90. So 3 90s makes 270. And you can see how this point has just gone all the way around to the backside. That's 270 degrees counterclockwise. That is what is happening here. Let's see if we did it and we did it right. There we go. We got 2 points for that. 2 points. All right, my people, there you have it. HHS rotations. Make sure you have your notes. Make sure you rewind, watch this over and over again. This took 26 minutes. Good luck.